All right, so it is the last week, and for our last week, we're going to be going over or reviewing perfect square trinomials and the method of completing the square to solve quadratic equations. So, all right, what I'd like you to do is try evaluating the following equation for x equals 1 and x equals 2 to verify whether it is a true statement. So x plus 7 squared is equal to x squared plus 49. So just plug in a 1 and a 2 and see if it works out, because if it's true, it'll work out. Let's pause the video and try that now. All right, let's see how you did. So if you plug in a 1, what we get is 1 plus 7 squared, following the order of operations. 1 plus 7 is 8. 8 squared is 64. But if we square 1 and square 7, we get 1 and 49. That equals 50. And 64 is not 50. So that statement is false. Let's try it with a 2. If you plug in a 2, following the order of operations, the left side evaluates to 81, and the right side evaluates to 53. And so that's false as well. Now, why is this? It's because that when a binomial, such as x plus 7 is squared, this does not mean that each term is also squared. I'm going over this because although we went over it in class, it is a very common thing, a mistake for students to make, and it's a common thing to forget. Even though you once knew it, it kind of looks like you should be able to distribute that outside 2 because there's a 2 on the outside. But sure enough, we've just demonstrated that that is not what you do. So what does x plus 7 squared mean? All right, well, every exponent is attached to a base, and the base here is the expression x plus 7. All right, and the exponent 2 means take the base and multiply it by itself. So x plus 7 squared means x plus 7 times itself. And so what we do is we multiply, and what we get is x squared plus 7x plus 7x plus 49, and that simplifies to x squared plus 14x plus 49. Now, this is a trinomial, just like, the trinomials we know how to factor, and the quadratic trinomials we use in quadratic equations, but it's a special type of trinomial. It's called a perfect square trinomial. And just like perfect squares are the result of integers squared, like 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, so 1, 4, and 9 are perfect squares. This trinomial is a perfect square trinomial because it is the result of some binomial times itself, or some binomial squared. Now, there's a way to describe all perfect square trinomials, and we can do this by representing a binomial as a value a plus a value b squared. And when we expand this out, what we get is the following. A squared plus 2 times a times b plus b squared. And now we can conclude that a binomial squared, all right, or this notation, means a binomial times itself, and it always results in a perfect square trinomial which will always have the form a squared plus 2 times ab plus b squared. Okay, now that we've learned that a perfect square trinomial is just the result of a binomial squared and always results in the form a squared plus 2ab plus b squared, let's see how we can use this property to easily identify perfect square trinomials. So all we have to do is find a way to rewrite this trinomial in the form of a squared plus 2ab plus b squared, and we know that it must be a perfect square trinomial. So I would suggest first trying to find your values of a and b. So those are pretty easy to find. Your first term is just a squared, and your third term is just b squared. So if we were to take the square root of the first and the third term, we should find our values of a and b. So the square root of x squared is just going to be x. The square root of 49 is going to be 7. And I'll mention that it could also be negative 7. That's not going to be useful here, but in your assignment, you're definitely going to need to consider that possibility. And I'll give you an example of why you'd need to consider that in just a second. But so the square root of 49 is 7 or negative 7. So now we found our a and our b. It's either x and 7 or x and negative 7. So let's use 7 and see if we can rewrite this trinomial using the values of a and b, or x and 7, in this form. So since x is our a, we're going to write x squared. Then comes 2 times a times b. So it's going to be 2 times a, which is x, and b, which is 7. And I'm going to write b first. And the a is x. And then, of course, the last term is just b squared, or in this case, 7 squared, which is 49. So 7 squared. All right, so does this expression, is this expression equivalent to the trinomial we started with? All right, and sure enough it is. X squared is equal to x squared. 7 times 2 is 14, times x is 14x, and of course 7 squared is 49. All right, so because we were able to rewrite this expression in the form of a squared plus 2ab plus b squared, we can verify that it is indeed a perfect square trinomial. Of course, you could always factor this, and if it ends up being a binomial squared, that's also another way to verify that it is a perfect square trinomial. In the case that, let's say instead of, if 14 wasn't positive, but if 14 were negative, that's when we'd have to consider this negative 7 to be one of our possibilities. Because if we put a negative 7 here, then that would end up being x squared plus 2 times negative 7, which is negative 14 times x. And then, of course, negative 7, got to put that in parentheses, negative 7 squared is going to be positive 49. All right, so that's an example of why you might need this to consider both possibilities here. So let's take a look at this second trinomial. What I'd like you to do is pause the video and see if you can rewrite this trinomial in this form. And again, I suggest trying to find the values of a and b first, because you're going to need those to deconstruct your expression. All right, so let's pause the video now. All right, let's see how you did. All right, so the square root of 4x squared is going to be 2x. And the square root of 9 is going to be 3. And of course, you know, this could technically be negative 2x, although I don't think it ever will be. But this last one will, you know, you should consider the possibility that it could also be negative 3. All right, so now we have the value of a. Our a is 2x, and our b is going to be 3. So let's try to rewrite this in this form. So we've got 2x squared plus 2 times a, which is 2x, times b, which is 3. And then, of course, we've got our b, which is 3 squared. And let's see if that matches. 2x times 2x is 4x squared. 3 times 2x is 6x, times 2 is 12x, and 3 squared is 9. So we verified that this, too, is a perfect square trinomial. All right, the next thing we're going to go over is the technique of completing the square. And this allows us to take an incomplete trinomial and find the missing value that'll make it a perfect square trinomial. So let's say we start out with the expression x squared plus b times x. All right, like we have here in this first expression, x squared plus 12x. Well, there's some magic value here that'll make it into a perfect square trinomial, which means it can be factored into a binomial squared. All right, how can we easily find that value? Well, all you need to do, all right, is add the following value: b divided by 2 squared. In this case, you take the value of b, you divide it by 2, and then whatever that value is, you square it. So let's see if this works. All right, here we're going to take 12, All right, 12 divided by 2 is 6. So we're going to take 12 divided by 2, and then we're going to square it. All right, and then when we square that, 12 divided by 2 is 6, and 6 squared is 36. So what we can do is write a 36 here, and this should be a perfect square trinomial. Now, you can go ahead and try and factor this trinomial the good old-fashioned way. Two factors of 36 that add up to 12 are 6 and 6. So this factorization would be x plus 6 times x plus 6. But if you notice, the property doesn't end here. It states that if you have a perfect square trinomial in this form, then it will always be factored into x plus b over 2 squared. So if we know what half of our b is, all right, or what half of 12 is, we know what goes over here. All right, so what's 12 divided by 2? Well, that's our 6. So we just have to write x plus 6. And then when we square that, we should get this perfect square trinomial. All right, let's go through another example. Here we have x squared minus 2x plus something. So what is that magic something? To find that magic number, all right, all we have to do is take the coefficient of x divided by 2 and then square it. Now be very careful. We have a negative sign here. All right, so what we have to do is take negative 2 and divide it by 2, and that becomes negative 1. And negative 1 squared is positive 1. Now, here's the tricky thing. When you want to go factor this, all right, if you're going to use this property, you have to remember what b over 2 was. So that's why before I wrote 12 divided by 2. Here I could have written negative 2 over 1. And I'll do that over here so we can see it more clearly. Negative 2 over 1. And that's what we squared to get 1. All right. However, if we want to easily factor it, we need to know what our b over 2 was. So negative 2 over 1 is negative 1, so this can be factored into x and negative 1 squared. Now for these types of trinomials, you can probably just factor this using the good old-fashioned factoring methods that we've learned. But when we get to more complicated expressions, excuse me, where we're dealing with fractions, you're going to want to use this property because it's going to be a little tedious to find the answer. So here, let's see what we've got. So to find this magic number, we need to take negative 3 divided by 2. Negative 3. Actually, let me write this over here. We're going to take negative 3. We're going to divide it by 2. And then we're going to square it. So what does that give us? Well, we can't really simplify negative 3 over 2, but we can square it. Negative 3 over 2, or if you recall, if you have a quotient and you raise it to a power, you raise the numerator to that power and you raise the denominator to that power. So what we end up getting is 9 over 4. We just square the numerator and square the denominator. Now, as you can see, this is not a trinomial that we want to factor. I don't want to go looking for factors of 9/4 that add up to negative 3. So, I mean, you're free to, but I'm going to use this little property right here. I'm going to remember what b over 2 was. b over 2 here was negative 3 over 2. So I know, because the property tells me so, that this factorization is going to work out. X minus 3 halves squared is going to be x squared minus 3x plus 9/4. Now, you're free to check this. Go ahead and expand this out, multiply x minus 3 halves by itself, and sure enough, you're going to find that you're going to get negative x squared minus 3x plus 9/4. All right, and for our last one, this one is about about as complicated as it's going to get. If you have x squared minus 5/4 x plus something, how can we find that something if what we're trying to do is to create a perfect square trinomial? Well, all we have to do is take negative 5/4 and divide it by 2. Now, if you recall, if you take negative 5/4 and divide it by 2, that's the same as multiplying by 1/2. So that gives us negative 5/8. So we take negative 5/8 and we square it, and what do we get? Well, we get 25 over 64. Again, is this a trinomial that you want to try factoring? And the answer is no. So we're going to use this little property. All right. Now, what did we square to get 25 over 64? Or what is the value of b over 2? That's why I wrote it like this. We've got negative 5/8 is what we squared to get 25 over 64. So negative 5 over 8 is just our b, negative 5/4 divided by 2. So where that's going to go in the factorization, x minus 5/8, and there we go. We've successfully factored this perfect square trinomial. So just to recap, if you are given an expression in the form of x squared plus bx, you can turn this expression into a perfect square trinomial by adding the value b over 2 squared. Once you do that, what you'll have is a perfect square trinomial, which we know can always be rewritten or factored into a binomial times itself, or binomial squared. That binomial will always take the form of x plus b over 2 raised to the second power. Okay, so you may be wondering why we've gone over perfect square trinomials and how to complete the square. It's because for our very, very last concept, we're going to learn how to solve quadratic equations using the method of completing the square. If you look at the following quadratic equation, x squared plus 12x minus 5 equals 9, if you play around with it, you're going to find that you're not going to be able to solve it by factoring, which means you're going to have to use the quadratic formula. Now, the quadratic formula is kind of a cheat because it's just a formula you plug numbers into. I never told you where it came from. Now, in order to understand where it comes from, you're going to have to know how to solve quadratic equations by completing the square, because that's really how you solve quadratic equations. The quadratic formula is just doing all the steps we're about to go through all at once. So let's go ahead and see what we can do. So we know that if we are given, or if we start with an expression x squared plus bx, that we can make a perfect square trinomial from that. All right, and we're going to use this to help us solve this quadratic equation. Now, if you recall, we can't solve this equation right now because x is in two places. All right, we can't solve equations when x isn't in one place. We can't undo it. All right, so we're going to use this property to help us get to a point where we can undo. So the first thing I'm going to do is I'm going to isolate this expression right here, x squared plus 12x. And I'm going to do this by adding 5 to both sides. So that's going to give me x squared plus 12x. And since I added 5 to the right side also, that gives me 14 over here. Now, I know that if I want to turn this expression into a perfect square trinomial, I need to add b over 2 squared. So I have to take my b value, 12, divided by 2, which is 6, and then square it. And that gives me 36. Now, if I'm adding 36 over on the right-hand side, I have to add 36 over to the left-hand side. All right, so to be clear, what I'm doing at this step is I'm applying the addition property of equality. All I'm doing is adding 36 to both sides, but I'm doing this for a very specific reason. I'm trying to create a perfect square trinomial over on the left-hand side. Now, why would I be doing that? It's very simple, because now I can factor this trinomial into the form of x plus b over 2 squared, or in this case, x plus 6 squared. Over on the right-hand side, that's going to give me 50. And now, if you notice, we have an equation that we can undo. X is in one place. It's no longer difficult. All we have to do is identify the operations being applied to x and just undo them. So x is being added by 6, and then we're squaring it. So to undo it, we're going to take the square root of both sides and subtract 6. So let's take the square root of the left side and take the square root of the right side. Now, the square root of something squared, or a base squared, is going to be that value. So the square root of x plus 6 squared is going to undo the exponent, and we're going to just be left with x plus 6. Now, the square root of 50 is going to be positive or negative square root 50. The square root of 50 can't be simplified, so we're just going to leave the symbol here. But whenever you take a square root of a value, you always have to remember that part of that value, or one of the possible roots can be positive, and the other root can be negative. So the square root of 50 is positive, whatever this is, and negative, whatever this is. And when solving quadratic equations, you have to consider both possibilities. So now all we have to do is subtract 6 from both sides. So that's going to give us, and I should tell you, you should try to avoid writing values after the radical sign. So I'm going to put the negative 6 that would go over here on the right side over here before the square root 50. So now what we have is x equals negative 6 plus or minus the square root of 50. And sure enough, that's the answer. If you take that decimal and plug it back into the original equation, all right, you're going to see that it works out approximately, because the square root of 50 is going to be an irrational number. So let's try one more before you try it on your own. Let's try x squared plus 2x plus 2x minus 1 equals 5. Now again, this is not a trinomial, or you can't create a trinomial that can be factored. You can't solve this by factoring. You can only do it using the quadratic formula, or now you can use the technique of completing the square. So why don't you try this one on your own, and I'll go through it once you're done. Pause the video now. All right, let's see how you did. So my first step is to isolate this expression, x squared plus 2x, because that's what I need to start with in order to create a perfect square trinomial. So x squared plus 2x. And then to get rid of this negative 1, I'm going to add 1 to both sides. So that's going to give me 6 over on this side. Now, to create my perfect square trinomial, all I have to do is divide the coefficient of x by 2 and then square it. 2 divided by 2 is 1, and 1 squared is 1. So that seems pretty simple. However, because I added 1 on the left side, I also have to add 1 on the right side. All right, so just to reiterate, all I'm doing is adding the same value to both sides, and I'm not arbitrarily choosing this value. I'm choosing 1 because it will help me create a perfect square trinomial on the left-hand side. This allows me to factor this into x plus 1 squared. And over here we have 6 plus 1 is 7. And now we've created an equation that we can undo. X plus 1 squared. We're adding 1 and we're squaring it. To undo it, we're going to take the square root and then we're going to subtract 1. So let's take the square root of both sides. Now the square root of something squared is that something. So that's going to be x plus 1. And the square root of 7 is going to be a positive and negative irrational number represented by square root 7. Now all we have to do is subtract 1 from both sides, and we end up with x equals negative 1 plus or minus the square root of 7. All right, and if you want to turn this into a decimal and plug it back into your equation, you'll find that the left side approximately equals the right side. It's approximate because you're not plugging in this expression, you're plugging in a decimal equivalent. Furthermore, you can use the quadratic formula to verify that this is indeed the right answer. You might have to do that on your assignment, since some of you might have not done this before in class. All right, that's it. This is the last concept for the year. Let's get started on our assignments and finish up the year strong.